Okay, good morning, welcome and thank you for joining us today. This webinar is part of our Industrial IT webinar series. My name is Chris Whitehead, I'm the Managed Platform Product Manager here at Solutions PT. And this morning's webinar is the best practice for managing legacy control systems. So in this webinar we're going to have a quick look at the challenges associated with managing old mission critical systems and aim to explore how our managed service offering can enable you to get the most out of your automation infrastructure today and also in the future whilst maintaining plant availability. Okay, so very briefly, our agenda for this morning's webinar, we're going to look at some of these control system concerns, some of the challenges associated with these, and then kind of looking at what we can do using our managed platform product set and how to best use these. I'm going to give you a brief introduction to the two we're going to talk about today, which is Auxilia and Proteus, and then we're going to just kind of recap with a summary of our best practices. So, to start with, what we're actually seeing in a lot of the research we've done recently is that one of the key highlights there is the EEF, the manufacturers organisation, are kind of suggesting that the whole industrial organisation out there is kind of gearing up for the fourth industrial revolution, or 4IR as they call it. We've also seen the ARC Advisory Group, from their calculations, estimate that around $65 billion worth of what these automated control systems are nearing the end of their usable life, which is a huge sum of money and a huge amount of infrastructure that's actually affected by this. And also in our own research, we've seen many of these manufacturing plants, a lot of the infrastructure that's used there is now over that 20 years old. So this is real legacy systems that have not been touched for years and have got not a lot of life left in them. So some of these key concerns for the control systems, obviously, we've got system failures, the skill shortages, connectivity issues, a lot of unsupported operating systems out there, and not all these systems have got upgrade paths available to them. So one of the other key areas in this is actually the skills shortage, and this is because there's a lot of these systems were put in, 20 years ago, as we've just said. And there hasn't been the knowledge transfer. There isn't the new set of engineers coming through the training now that understand these older systems. And rightly so, if you're a new engineer coming into this market space, there's no real benefit in understanding the older technology because it's not stuff you're going to be working with. And actually some of the research we did last year indicated that we estimate there's around 80,000 engineers and technicians in shortfall every year of what's actually leaving the workforce through to what's actually coming into it. Now also, in other events that we run, we ask for a lot of our feedback, and some of these feedback, this feedback is really useful to us because it allows us to collate this kind of information. So what we've seen from last year's set of events, that around 58% of our current customers see cybersecurity as a main priority over the next year. And actually what we've seen is a lot of these companies as well also understand that cybersecurity now poses a barrier to adopting new technology. So all these new upgrades and systems that are available, people are now starting to think about cybersecurity and connectivity before other issues. And finally, the last key point there in the middle is that the small to medium businesses are losing thousands of pounds a year due to network downtime. And this is not just the actual applications. This is system failures, the ability to repair or remediate an elderly control system or something that you haven't got the hardware for anymore. So all these challenges, are facing most of these current control systems that are now what we consider legacy. So if we break it down a little bit further still, some of these challenges is the ability to find compatible hardware. So if you've got a system that's put in 10, 15, 20 years ago perhaps, you've got a very, very old set of hardware and you've got a very, very old set of operating systems. The chances are you're not going to find the new hardware nowadays that will work with that system. So if you had to try and find an old Windows 2000 box, for example, pretty much your only source of sourcing that is going to be something like eBay or Craigslist or Gumtree, or hoping that someone's got one sat spare in the garage that you might be able to purchase. Either way, it still presents you with the challenge of putting legacy hardware into a running control system. Also, we're now seeing a lot of places have actually got less resources to work with. The teams and the numbers are being squeezed all the time, so there's actually less feet on the floor to do the work. So you're going to spend more of your time firefighting than investing time in looking at new technologies and overcoming these issues. And that goes hand in hand with the fact that you now in your team will have less specialists and more generalists. So you've got less people doing the same amount of work, you've got less people that can specialise in one particular area, and a few people that actually know more around a broader range of subjects. Now there's also this lack of legacy knowledge occurring, and that is through to the fact that there's an ageing workforce and there's this gap in skills that are occurring. So as people are leaving the businesses, retiring, there isn't that legacy system knowledge. So these guys, when they put this in 20 years ago, haven't got everything documented. A lot of it's in their heads. So when these new guys are starting, there isn't documentation to refer to, and they've not got the experience and the hands-on flying hours to come and work with a system like this. So it kind of leaves you in a bit of a shortfall. We're also seeing more and more production efficiency drives. So plants that weren't 24/7 previously are now increasing their hours to get the most return of their equipment and systems as they can. So rather than actually building new equipment, they're making the current hardware and the current stuff work for longer or work more hours in the day. And again, this presents another challenge, and you've got a reduced window of downtime where you can actually fix these things and take a proactive maintenance approach to it all. And then we've got the issue with remote sites. So as remote sites have always been a challenge as such, but with a legacy system more so. If you've got remote little islands of automation that are occurring, obviously you've got connectivity issues to that, and that presents a security challenge. But if you've got a couple of smaller sites away from like a central hub, for example, you don't necessarily have the skill set on site to maintain that equipment, and you've probably got those guys not working the same range of hours that you would have on a main site. So again, this all adds into and compounds the fact that legacy systems are becoming a more, a meaningful challenge to address. So if we have a quick look at some of the security threats of this, obviously we've got the risk of OS vulnerabilities. When Microsoft end of life an operating system and they stop producing patches and updates for it and hotfixes, well, from that point on, anything that's detected isn't going to be fixed. There isn't going to be a way of getting Microsoft on board to write just one more patch for you. And that in itself presents a hole in the security fence that's not going to be patched, not going to be fixed. Now, I've put ransomware in, and unless you've been living under a rock for the last year, you've definitely heard of some of the major outages that people, and big people as well, have occurred through the infections of ransomware, and how prevalent these things are in the modern digital space that we've got. So some of the ransomwares that you've probably heard of the last couple of years, which are quite key ones, are like WannaCry and Petya and Bad Rabbit. What you don't see is the other 490-odd thousand that are produced every week with different signatures, with different payloads and different ways of decrypting that data. So it's a constantly evolving threat landscape. There's continually new versions and flavors of ransomware coming out that maybe don't grab the same headlines that these do, but are still a definite threat to be aware of. Likewise, although ransomware kind of grabs the headlines, virus infections are still prevalent. We still got a lot of customers who we currently manage systems for, we see a lot of virus infections. And these systems, when we're putting as legacy systems, as new systems 20-odd years ago that are now legacy, were designed to be air-gapped, and there wasn't the same cybersecurity considerations in the actual design of this equipment and these infrastructures. So as things and threats have evolved, the old air-gap way of doing things where control system wasn't connected to anything else provided some level of security. Well, that was undone when the USB pen drive was developed, and now we've got smartphones with a couple of gigs of data on there. All these prevent kind of sources of infection, and most of them are inadvertent. We've not really got kind of state-sponsored attacks over here currently. I'll say that there probably is, but nobody tells me about them. The point is, if someone in your plant plugs in a mobile phone into something they think they're just going to source the power from to charge the phone while they're working, that is actually a threat, and there's a method of actually getting the ransomware, the virus, or the payload, whatever it is you're trying to deliver, off the mobile phone without infecting that, without affecting the actual user's phone, but then it's actually in your control system. So your air gap has pretty much done nothing because it can be physically bypassed by a manual process. I talked very briefly about the connected enterprise as well. So we've got a lot of legacy kit out there, and now the whole way in which we're working is different. We've got an entire C-level of the organisations now want to see what's going on and kind of see real-time production stats on their iPads. But that does mean that the enterprise networks are now connected through to the plant. Granted, there's some security in there, but there's still open routes between the two areas of the network because ultimately they need to query what's going on low down in the actual infrastructure to kind of pull all those stats through. And those connections, as much as people try and protect them, are still a route and a method in which we can actually get information from one side of the network to another. And that goes hand in hand with kind of poor network design and security. And it circles back to when these systems were put in all these years ago, there wasn't the considerations around cybersecurity. It wasn't a case of, well, we need to protect against ransomware, we need to protect against these polymorphic worms, we need to protect against these zero-day exploits and OS vulnerabilities, because there wasn't the same headline attention to it, and there wasn't the same amount of people with the skills and qualifications to secure these things properly. And lastly, third-party devices. So that could be contractors coming in and helping to fix things. You've got someone coming from an SI where he's got his engineering laptop with him. You might even have a laptop that stays in the plant but goes around different sections of network. If that was to contract a virus or be hit with ransomware, even if it's just sat there idle at the moment and it gets connected to one network, then it jumps over to another section of network past another firewall and you plug it in somewhere else to do something else, you've essentially got something that's not been sheep dipped, hasn't been sanitized, and it's pretty much got the permissions to connect to any section of your network. And that's before we even get into the whole subject of mobile phones and pen drives on a plant that present a real risk. So, one key topic I do want to talk about is the whole model of break-fix and the fact it's broken. If you're still working with a break-fix model, you are 100% guaranteed of downtime. So when something goes wrong, that's your trigger to start fixing things. You are literally racking up those downtime minutes while you try to actually fix something. So if you wait for it to break before you start to take action or have a plan in place, then you are guaranteed downtime. And I would always raise the question, are your backups good enough? And this comes from the last 12, 18 months we've been asking questions of customers and we've been polling for feedback. And a lot of people say, yeah, we've got a backup. Well, I would second that question is your backup good enough? Can you prove that you can recover from it? Because you can have all the backups in the world, but if they're on a chain technology, and you've got one bad backup in there, the rest of the chain collapses. If you can't recover from those backup points, was there any point in taking them in the first place? That also brings another question in. If you are having to recover something that's broken, can you still source the hardware and the availability of it to actually be able to recover too? So if we use the old Windows 2000 analogy we talked about earlier, if you've got an old Windows 2000 system, can you still source hardware today that's going to be good enough to run that operating system on? Excuse me. We then talk very quickly about recovery time objectives, and this is something I think most people need to be aware of. And from the conversation we had previously, I don't think there's enough focus on this. If something does go wrong, how quickly can you recover? And, are we talking minutes? Are we talking hours? Are we talking days? I mean, God forbid you're talking more than days, because if you look at your cost of downtime and you've got an RTO that's in the days, then you're in a pretty bad situation, and you probably could do with spending a bit more time and effort in trying to address that and reduce that RTO for you. And out-of-hours incidents seem to be where the most challenges are presented, because you could say that 8 while 5 you've got the most guys in the office, so pretty much guarantee if something's going to break, it's not going to be while you've got a fully staffed set of engineers on site ready to fix the issues. It's going to be at the worst possible moment when you've got the fewest people, the fewest feet on the floor, and the least sets of skills in the business to help with that. And actually, coming back to what we talked about at the very beginning, this reactive maintenance model and this break-fix issue is kind of broken. And that's because we're now seeing this proactive, preventive maintenance occurring everywhere. So we've got the likes of the IoT of things. So these are small sensors and things like that that actually start to communicate when they're starting to go wrong. We've also got equipment like, if we just, very quickly look at a car. Years ago, you'd run a car. If something breaks, you take it to the garage and you fix it. You're off the road while it happens. The AA, for example, now runs a service called Car Genie, and this is something that connects to your car's ECU and monitors the parameters of your engine. And when things start to go wrong and anomalies start to appear, uses that method and that system to alert the driver as well as the garage and the AA centre to pre-warn you of something before it fails. And we could very loosely take that one step further as well around smart motorways, which no doubt if you've travelled around the country, you've sat on one or at least sat in the roadworks for one of them. The point is with this, rather than you hitting the traffic, this proactive system is now saying, actually, we're seeing traffic up front, but before this affects the guys behind you, we start to slow this down. So actually what happens is you don't really catch the traffic, you're just reducing the speed of what you're travelling at before you catch it all. But the point is this proactive system is becoming more commonplace, and people are rather spend the time and the effort to actually prevent issues before they get to the point of affecting production system, whatever it might be, and actually causing downtime or causing you an issue. So this moves on. I actually want to introduce you to two of our managed services that can help with some of the issues we've discussed today. These are Axalia and Proteus. So Axalia is our real-time infrastructure monitoring system, and Proteus is our backup business continuity and disaster resilience backup solution. So I'm going to start with a very brief video to Axalia, and hopefully this is playing okay on the webinar. So Axalia is our turnkey managed service. So this is where we proactively monitor and maintain any kind of key infrastructure. So this can be servers, workstations, switches, the actual PLCs themselves. Pretty much anything that's on the network that you see as critical, we set up a set of alerts for and then manage and maintain that. And this is pretty much like having someone from Solutions PT as part of your team. So you don't need a skill set on site. This is our 24/7 managed service. And like you can see on the screen at the moment, we see this through our Insight technology, so we can see a snapshot of exactly what's going on. So the whole point behind Managed Platform, the whole idea behind it, is that we kind of look at things in a four-step process. So monitoring the actual systems that we've got, we secure the data and back up them, so if something does actually go wrong that is unexpected, it could be power outage, server failure, something like that, that is pretty much inevitable to predict before it actually happens, there is a method to recover that system. The point is, with actually monitoring, we can make these predictions as when maintenance should best be performed, or where that time and investment needs to be spent. So not just talk about cash investments, but time investment as well. If we're seeing certain devices, systems, services that are away from its baseline of operation, so there's an anomaly occurring, we can feed that back on our monthly calls to actually discuss with you when, where your time and effort is best spent to remediate these issues. So actually, rather than firefighting, you're starting to get ahead of the curve and fix the issues before they actually cause downtime. And the whole point of this is to increase your operational uptime and efficiency and the availability of the systems that you're looking after. So Axalia, as I said previously, it's a 24/7 real-time monitoring system. So if you're not 24/7, this is a very, very easy way to move to a 24/7 support system without the additional resources required on site. We also collect a ton of data from the system around the items we're protecting, and we use that to build trending data as well as analytics. So we can actually look at the information that we're receiving back from the plant and make these recommendations as to where we can best place your time and investment, whether it's replacing something, whether it's resolving an issue, or whether it's actually looking at an upgrade. And also we can discuss upgrade paths and things like that with you. We actually have a monthly call with you as well, so this is we're not just going to farm over tons and tons of alerts that you've actually then going to fish through. So part of the actual services, we use our internal skill set and a very, very skilled team of engineers and technicians that we've got to actually look at the data and kind of, rather than just sending alerts, we use that data to kind of formulate a plan and ideas, and then we actually discuss that with you on a monthly basis to give you the best level of information that's most relevant to what you're trying to achieve. And the last line of that slide there is key, and it is basically Solutions PT become part of your team. So it's pretty much we're monitoring that stuff 24/7 for you. If you've got an issue, you can reach out to us and we can offer you the assistance where it's needed. So now I'm going to talk very briefly about Proteus. So Proteus is the other. I've changed it on there. It's taken a second. Sorry. So Proteus is the other half of our managed platform offering currently, and Proteus is a business continuity and disaster resilience solution. So ultimately, it's a fully monitored backup system currently. We have the ability to prove every restore point that we take, and we do this once a day at a bare minimum, which is where typically we pick the first same hardware that we use on site. And when we've got this to a Windows login screen, this is screenshotted, and then we send that across to you. So we can prove that the backups we've taken from that night, that the past day, wherever it might be, we can actually have the ability to recover from. So also in line with cybersecurity best practices, we encrypt what we're doing. Actually, the backups, the data, and the in-flight data is all encrypted to AES-256. If you're using our cloud services as well, the data centers are UK-based. Obviously, we've got two of them for replication, so if we back up to one, we replicate to the other. So for actual legislative purposes, if we had to prove where that data is, we know exactly what set of disks that's sat on and can physically show you those. So as I mentioned earlier, ransomware has been a key threat over the last 12 months or so, and actually that's allowed us to build in, a new feature within Proteus, which is ransomware detection. So we're looking at the delta changes between the backup points. So if we're infected at 10 o'clock in the morning, we would see a huge amount of delta change and a load of encrypted files, and we use a numerous set of algorithms to compare these against what we consider to be kind of ransomware activity, and we would raise an alert based on that. And then actually part of the services we wouldn't test one of these backup points to actually manually mount it and prove if it is a ransomware infection, so we can capture it quickly. Gives you the option to then isolate the system. We can recover in literally a matter of seconds. And again, this is a managed service, so it is like Solutions PT become part of either your engineering team, your support team. So you don't need the knowledge and the skill set on site, you don't need your own hardware. This is a solution we will literally install and maintain and manage for you. So it's pretty much, you tell us what needs to be backed up and protected, we do that, we guarantee we do that, and we prove that it's recoverable. So what we've got now is a very brief video around how quickly we can actually recover a system. So this is a demo laptop we normally use, and we're actually going to locally virtualize the system, so assuming that the hardware has failed or it's been misplaced. So actually now we're starting the virtualization. I'm not going to change any of the specifics of this, we're literally just going to start the VM up. So what you'll see is how quickly we can pick a backup point, and we could pick any one that's in the list there. We start the restore process. And once the actual system's up and running, we then just can use RDP to connect to it as if we would do on the network. Now this is essentially what we would do on a daily basis to prove the backup points for everything that we've got. So when we get to the Windows login screen, and you should see this in a second, we then screenshot this and send it to you so we can prove that these are bootable. So if this was a real disaster, I think we're running up to about the 2-minute mark to actually get a system that we've got protected, actually mounted as a separate VM and connected up. Now what you'll see now is the backup point, even though it's only an incremental backup point, we've actually got full connectivity, and you can see GoToMeeting there trying to start up as it would do on the physical system. All the documents are there that need to be, so the application data, any docs that we need, and also we've got the full application set as well. So if we click on Start now, you'll see that we've still got InTouch there, and we've still got all the standard Windows applications we'd use on this system. So the point is, in under 2 minutes, we can actually start this process up and actually get production back up and running. So this comes to that RTO discussion. Using Proteus, we're talking minutes, not hours, not days, God forbid, not weeks, but literally minutes while we nominate the system we need to spin up and actually get it connected to keep things moving. So I'll just progress this. There we go. I think we're done now. Come on, next slide. So actually now what it's done, we've turned the VM off, so we're literally just going to eject that VM out of the system, so we're back to where we were. There we go, you can see it stopping the VM now. Just wait for that to finish. Okay, so actually what we're also seeing a lot of customers doing is actually protecting legacy systems and virtualizing them in one step. So one of the basic features we've not discussed yet around Proteus is our ability to protect and virtualize it in literally one step. So on the left, you see I've got there a domain controller, a theme manager server, and also an InTouch server, and those are being protected to our Proteus Vault. Now, one of the other features within the Proteus Vault is to directly, take those backup points and mount them as VMs onto an ESX server. So on the right-hand side there, what we've got is, well, it could be a host, and we normally recommend a Stratus FT server. If you're going to put all your eggs in one basket, you may need to make sure your basket is as good as it can be. FT servers deliver the best in uptime, so actually what we do is directly upload those protected VMs into the ESX server and spin them up there. So that gives us two things. One, we've got a virtualized copy of the same legacy system now running on new hardware, and it's obviously being virtualized, it's hardware agnostic. But we've also got the option there, if we had to, we can still recover using the Proteus Vault to another piece of physical hardware to recover one of the physical systems if we needed to. So it gives us a few options, but it's a very, very slick and elegant way of being able to take a legacy system, protect it and virtualize it all in one step. Okay. So some of the key benefits of using Managed Platform, as I said earlier, it's 24/7 real-time monitoring, and this is monitoring and management of the key infrastructure. So the pure critical systems that are actually going to affect your operations, whether they be servers, workstations, switches, PLCs, etc., we can monitor it all. The BCDR technology, so the business continuity and disaster resilience, if something does go wrong, we have a method and a plan of how we're actually going to be able to recover that and prove it. And then it's actually a proactive support method, and this is delivered by a very skilled set of engineers. We spend a lot of time and investment at Solutions PT in ensuring that our engineers and our technical team are the best they can be. So we put a lot of investment into their training time, their personal development, and we make sure that the service they're delivering is absolutely the best it can be. So the point of that is that we're not going to have to keep handing off from like a first-line guy to a second-line guy. Pretty much the first person you're going to get through to on the phone is going to be able to sort out that problem out from literally a couple of quick questions and maybe a bit digging around into the actual customer data that we've got held. So to summarise, we help meet and manage the challenges associated with these legacy systems by actually monitoring and maintaining what you've currently got, as well as having a rock-solid backup disaster resilience technology to recover from should anything actually go wrong. Okay, so now we've got a bit of time for any questions and answers if are needed. Any questions in there? No. Okay. There's no questions so far, but if you do have anything that pops out in the future you want to ask us, please feel free to get in touch. All the information you should be able to see there. If you've got a Solutions PT account manager, please reach out to those guys, and happy to take any questions you might have on the subject. Thank you very much for your time.